Now we will take it forward and we'll talk about one very interesting and important concept of load balancers. Okay. Now when you talk about before I proceed further on the load balancers, I would like to know like how many of you tried creating your static website. I asked if you can deploy for full stack website on EC2 instance. You do. It is you it is very hard to deploy a full stack website on top of EC2 instance. Okay, because it will be dynamic, right? Okay. Uh, you can definitely do that, but there will be a lot of you know dependencies and the other things that you have to work on it. Yeah. Okay. Right. The second one can't delete the either one. Okay. So you are not able to delete the EC2 instance. Okay. You have a button called terminate EC2 instances. So you can do that. I okay. There's what kind of error you are facing that if you can tell, then we will be able to help you out. Okay. Dynamic site and a user account. Yeah. All right. So, yes, they will be they will be you will be able to see them in your list, but you cannot do anything with them, and they'll get vanish off after some time. Okay, Brent, the terminated EC2 instances. All right. Okay. So now let's go ahead and shall we start, team? Please let me know in the chat window. Are you guys ready to with the No, I mean, I hope you guys are taking notes and all also. Yeah. Okay. Let's get started. So now let me tell you one very important thing, and we will start our discussion with that only. Let's say that this is your EC2 instance. Okay. I created an EC2 instance on Linux. Okay. And this EC2 instance has 2 core CPU. Okay. 4 GB RAM, and let's say 30 GB hard disk is there. Okay. 2 core CPU, 4 GB RAM, and 30 GB of hard disk is there. Okay. Now, when you basically and we have deployed a static or a website on top of it. Let's say that thinkloudly.com. Okay. .com. Okay. Now, whenever a user is trying to access this website, the website will utilize the resource, right? The website will utilize these resources to show you the content, right? At the end of the day. At the end of the day, whatever the application or the services that are running on top of your computer or a server, they are going to utilize these resources to perform, okay? To show you the content, to give you the results, okay? So now in that case, I mean, if you just open up your task manager also in your computer, you can see that. Let me try to open it up. Hold on just a second. Why can't I? Okay. Okay. So if I open up this task manager, you'll see that in my computer also these many resources are running, right? So sorry, these many applications are running. So Slack is there, which is taking at least actually 85.3 MB of the memory, right? the Zoom is taking 4% of CPU, right? Altogether, my computer's 10% of CPU is being utilized, 87% of memory is being utilized, 1% or 2% of disk is being utilized, right? Right? So you can see here also how much the things are going on. Okay. Now, my point here is that to handle each and every request, your application is using or utilizing the resources out of this. Okay. Now let us say that to handle one user, your website is taking 1% of this resource. Okay. So how many users it will be able to handle when it will reach out to 100% of utilization of the resources? 1%, one user. So in total it will be 100, right? So 100 users are when 100 users are hitting your website, around 100% of utilization will be done, right? Now, what will happen when 101th or 110th user will be hitting your website? The website might go slow, right? Website might crash also at times. Okay. Hmm? These kind of problems can come. Hmm? Right? Okay. Now this is a problem. Okay. But what is the solution? What can I do? In the first class, we discussed this, that what can be done for this, right? The EC2 instance has limited CPU, limited RAM, network capability, or the number of requests it can handle, and eventually the server becomes slow or crash. So the first problem is too many requests, too many users are hitting one server which cannot be handled, okay, easily. So yes. So basically you can have two options here. Thank you guys. Many of you have in yeah. So there are two solutions that we can do here. Is first, I can add one more server exactly same size and configuration. Okay. Or what I can do is that I can increase the capacity of this server itself. I can make it 2 core to 4 core. I can make it 4 core to 4 GB to 8 GB RAM, or 30 GB to 50 GB hard disk, right? So either I can go for vertical scalability, or I can scale it up for horizontally, right? These are the two options. Now, the best option, which could be the best option? Okay, when you add a new server, or when you add or increase the capacity, which is the best one? Now take it like this. See, when you add a new server or when you add a capacity, whenever you will be adding or increasing the capacity of the server or upgrading the server hardware, it has to go under maintenance also, right? It will go down also at a particular point of time for a bit of time, right? So that is again going to be a problem for your high availability, right? And what if that server not, again, one more problem can come. One problem is that the load, right? How because one server cannot handle lot many requests. One problem. Second problem can come that what if that server goes under maintenance, or what if the server goes under you need to update the server, patch the server, or it gets failed also at times. Okay, that is also one of the problem, right? So it is best to get another server added, right? Hmm? Right, you you generally should add a new server. Okay, fine. We are going to add a new server, right? I hope everybody agrees with me that we will be adding a new server, right? To the website, exactly new server, wherein it will be having some or right exactly same application or the website deployed on top of it. Okay, cool. Yeah. Now we have two EC2 instances, okay, EC2 1 and EC2 2. I have two EC2 instances on top of which both of them I have tc.com, thinkloudly.com deployed, the same server, okay, good, right? Now different users will be hitting my servers and I'll be able to send the request, right? But who is going to tell that you have to reach out to first server or you have to go to the second server, right? Yeah. So who is going to tell you that which server I have to reach out? To which server I have to reach out? Again, that is again a problem, right? Hmm? Okay. So for that, yeah, that is where we need a load balancer or somebody in between who can actually help you out to direct your traffic, right? The load balancer, the elastic load balancer, right? So which server should the user go to? Okay, you cannot tell your user that, okay, boss, you have to reach out to this IP address and you have to reach out to this IP address. No, right? It will be really hard, right? So you need a load balancer. Now all my users will be hitting to the load balancer, and this load balancer will be deciding which user to be sent to which EC2 instance, right? And this actually solves one another problem, team. So two problems I discussed. One is that the distribution of the load. Okay, the first thing that a load balancer do is that it distributes the load, right? The traffic hitting to your website will be distributed based on the availability capacity of the server, and there are many other factors that I'll be talking about later on, but for now, just understand that a load balancer will act as a distributor of the traffic of the load to the EC for the website. Okay. Now, second thing that we discussed earlier only, that what if this server gets failed? Okay. Then also I have this other server available. Okay. So without load balancer, how my users will be able to know that which is the healthiest one? Right? It won't be possible, right? But what does a load balancer do? It has a facility or a feature called health checking. Okay, it has a feature called health checker. What it does that it will keep on checking your server's health at a particular interval of time. Okay, and if the server is unhealthy, it will not send the request to the unhealthier server. It will send the request to the healthiest server or available server. Okay, the server which is up and running. So these two problems it is solving, right? And the third problem what it is solving is that, again, if this server goes down, second server is there, and or let's say that I have two different servers having two different IP addresses. Okay. Now let's say if there is no load balancer, I'll have to give my users two different IP addresses, and I'll have to tell them that, boss, go ahead and reach out to this or this, any of these, right? Which is a problem. Okay. as a user utility problem, or it is not good thing. What load balancer does, that it act as a single point of contact. Okay, now as a user I don't have to worry about the IP addresses or the domain name or whatever, that okay boss, uh, mm, single point of contact, which server should I reach out to or which server should I not. Okay, it is the headache of load balancer. Okay, the DNS of the load balancer, domain name system of the load balancer, will be deciding and sending, and it will be acting as single point of contact for the website. Okay, for the EC2 instances, all users have to just reach out to one single domain name or one single DNS name. Okay, that's it. So the load balancer receives the request and decides which EC2 instance should it be handled. The load balancer will act as a single point of contact. Okay, the load balancer will act as a health checker also, and the primary function of the load balancer is to distribute the load. Does it make sense, team? Yeah, all these three features are good. Okay, yes, round robin, very good. So that again, initially the basic load balancers works based on the round robin methodology, but there are the load balancers which are, I mean, there are different type of load balancers which works on based on the, like you can also create policies in the load balancers, like weightage based policy or latency based policy or primary or secondary based policies. Okay, to answer Bill said just round robin, so I just tried to explain that part. Okay, all right. So let's go come back to the discussion. Okay, so it is exactly same, like let's say that you are in a restaurant. Okay, and there are in the restaurant there are three counters. Okay, counter one, two, three. So customer will do not have to worry about like okay which counter is available, which counter is not. It is the receptionist work who will be directing the customers to the right set of the counter and all. Okay, the user doesn't know about all the EC2 instances. Okay, they simply access www.thinkcloudly.com, and the DNS will be the pointing out the application towards the load balancing layer, and load balancer distributes the request to the available backend instances. Make sense? Okay, what if the load balancer itself is very good? Load balancers itself fails, then good question. Basically, load balancers also have uh, generally what happens. This load balancer is this is then all EC2 instances will, even if it is healthy, even if all if a load balancer goes fail, and even if all the servers are healthy, they will be the website will not go down. Okay, AWS load balancer itself is designed to avoid being a single point of failure. Okay, when you create an AWS elastic load balancer, you don't normally get one physical machine sitting in front of your EC2 instance. AWS runs the load balancer infrastructure across multiple availability zones. Okay, so it will be like this, but it was a good question. Okay, just a second. Yeah, so it will be like your users will be there. Okay, and then all your users are hitting your AWS LB load balancer, right? So later on there will be availability zones, like maybe availability zone A or availability zone 2 or B. Okay, and then you will be having ALB nodes. Okay, and within that you will be having your EC2 instances and all. Okay, like that you actually design it out. Hmm? So even if one availability zone is failing also, the other is up and running. So conceptually there is not just like the user is there, one load balancer is there, and EC2 instances are there. Okay. So I hope I was able to answer your query, Ravi. Okay. So what if one part of the load balancer infrastructure fails? AWS can route the traffic through healthy load balancer infrastructure in another availability zone. Okay. Cool. All right. Okay. So now I will talk about one more thing. There are, okay. Let's go ahead and first of all create a load balancer, and then eventually we will talk about other features of the load balancer and the type of load balancers. Okay. Okay. So I will be using I'll be using Linux operating system. Okay. Okay. On EC2 instance to deploy a static website. Okay, we will create two Linux EC2 instances, deploy exactly same static websites on top of them, and we will create a classic load balancer on top of AWS infrastructure. Okay. All right. So let's go ahead. Shall we start, team? Okay. I hope you all are ready. Okay. So let's go ahead and start it out. These are different things. Okay. The elastic load balancer, right? So it distributes the traffic across multiple targets. Now, again, there are some terminologies of the load balancers also. We'll talk about that. Does ELB only handle web? No, I mean it can handle the other type of request. Elastic load balancers handles a lot of things, like you can have URL based routing, you can have intelligent load balancers also, there application load balancer. Multiple applications can also be handled using one load balancer. There are many other things that I'll be talking about it eventually. Okay, so let's go ahead and first of all do start with the lab. Okay, so let me know if you can see my lab screen. Okay. Please confirm if you can see my AWS lab screen. All right. Okay. So now let's get started. Okay. So first of all, we have to create two EC2 instances. I'm creating both of them in one same region. Okay. So I'll go to EC2 instance. Okay. All right. And then I'll click on launch instance. Okay. Now Linux, excuse me, Linux EC2 1. Okay. Now I'll select Amazon Linux. Okay. Now scroll down quickly. I'll keep the same T3.micro free tier eligible is fine for me. So I'll go ahead and I already have a key pair, so I will not be creating a new one. Okay. You can also select the existing key pair, which is if it is already available in your computer or in your you already have if you already have your key pair. Okay. All right. Now scroll down and network setting. Yesterday we discussed about AWS security group also, right? So SSH is already checked in. I'll check in the HTTP also. Okay. So that the website will be accessible over the port number 80. I scroll down, the storage configuration can be, it is fine. Okay. I am okay. All these things are okay. So now I'll just launch the EC2 instance. Okay. Team, what you can do, like you can also create more than one EC2 instances at the same time. You just have to remove this name can be given later also, and here you can make it 2 or 3 or whatever the number of servers you need. Okay, right? So can we use one key pair? Yes, you can use one key pair for multiple instances, we do. Okay, Yeah, so here I'm making this number of instances two. So it will create with the same configuration two different EC2 instances. Okay. I hope it is clear to all of you. Right? Please note this. Okay. Now I'll go ahead and click on launch instance. Okay. So both of my EC2 instances should get ready in a bit of time. All right. So you can see that I have two EC2 instances ready at the same point of time. Right. Now, why do you not? Yeah, if I'm naming it at the same point of time, both EC2 instances will be given at the same name. Okay, right? Then how are we going to decide that which one is which one? Okay, based on the instance ID, definitely we can, but it becomes hard to remember these numbers. Now I'll name them. Okay, so I can name it like Linux underscore EC2 1. Okay, and I can just name the other one also here itself. You click on the pencil icon and then just name it EC2 2. Okay, so it is clear to all of us. Yeah, so now we have two different EC2 instances ready with the same configuration. Okay, right? So now what I'm going to do is, like, first of all I'll connect the first one, and I'll scroll down, click on connect, and then we will be running a few commands to get the Apache web servers installed and all. All right, so this is my first server wherein I'm working. Okay, and later on I'll be configuring the second server also. Okay, till now everything is clear to all of us. Yeah, I hope everybody is with me. Hmm? All right, so now I'll type sudo DNF update hyphen y. Please correct me if I'm doing anything, if I'm missing any commands and all. Okay, I hope you guys already have made a note of the commands and other things. Okay, so now I'll just update this EC2 instance. Okay, and meanwhile I'll connect the other EC2 instance also. Okay, so that we can run the command simultaneously. All right. So this is where first command is going on. Okay. So for in first EC2 instance, I have already updated it. What I'll be doing is that I'll try to copy this and I'll run the same command over here also. Okay, it didn't get copied. Okay. So sudo DNF update. There is one more way to deploy the code on top of EC2 instance, even at the same time when you launch the EC2 instance. Okay. Session manager. Okay, you're connecting with session manager. You don't have to use that word. Okay, you can just click on in browser option and select the very first option, which is EC2 instance connect. Okay. Uh, Yeah, I hope I was able to answer your query, but just try that one. Okay. When you go to the EC2 instance, click on connect, and the very first option comes in browser option, EC2 instance connect, and then you just select the connect button, orange color button. You don't have to select this SSM session manager. This is for direct running the commands and all. Okay, on top of the EC2 instance. Okay. Currently, we are using this one, which has a public IP address. Okay. I hope yeah, okay, cool. All right, so now the both of my EC2 instances are updated. Now we will run the another command to install HTTPD. Sudo DNF install HTTPD hyphen y. Okay, let me try to, just a second, just a second. Okay, so the HTTPD also is being running. Okay, sudo DNF install HTTPD hyphen y. Okay, let it install over here also. So HTTPD installed. Okay, Apache is installed. Now it is time to enable it. Okay, so again sudo system systemctl enable uh, hyphen enable HTTPD, right? Okay, now we'll run this. Okay, it is enabled. Hmm. The same command I can run over here also. Sudo systemctl enable HTTPD. Okay, done. Now the important part. Till here everything will be same. Okay, yeah, but after this we will have to do one thing. Okay, okay, so we have just enabled it. We have to start the service also, right? Sudo system ctl start http. Okay, all right. So now it is almost ready. Okay, let's just check it out, and then I'll put the HTTP code also. Okay, sorry, yeah, HTML code. So this is my public IP address. Let's try to access it and see whether it is accessible or not. Mhm. Okay, so it is working, right? Now what we have to do, rules we already, when we are creating the EC2 instance, I checked in two boxes, one for HTTP and one for SSH. So during creation of the EC2 instance, that time only we created the security group rules. Okay, so can we use one key here? Yeah, yes. Okay, now this is one important part. So we have to update like sudo, excuse me, sudo nano, okay, slash var slash www slash html slash index dot com. Okay, sorry, not html, sorry. HTML. Now when I get into this, I will write only one liner code. Okay. H1 for heading. Welcome to server 1. Okay. Welcome to server 1. Now let me close the codes H1. Okay. I can add one more. Just a second. Okay. Then what I can do is that I can write P. This is the website. Yeah, this is the ELB lab. Okay, this is CLB lab. Okay, and I can put it like that. Okay. Hmm. Perfect. Now control X, press Y, and that's it. Enter. Okay. Now if I just refresh it, my first server is ready. Okay, cool. Now I'll do the same thing, similar thing for the second one also. I'll first of all start it. Excuse me. Start. Okay. Now what I'll be doing is that I'll write the command called sudo nano and slash var slash www slash html, okay, slash index dot html. Now here We will write the line of code, but we will just keep it like as server 2. Okay, let's copy this. Instead of server 1, we will keep it here server 2, so that we actually will be able to know that which server is which one. Okay. Hmm? Okay, cool. Control X, Y, and enter. So both of our servers are ready. Okay, team. I hope we all are at the same page. Let's test this one also. HTTP. I'm using HTTP, not HTTPS. HTTPS is generally used definitely in real time. Okay, and that needs the SSL certificate configuration. Okay, why it is not working? Because of by default it will take S. Okay, right? So both of my servers are up and running. Okay, clear to all of us? Yeah. Hmm? Now what we are going to do is that we will start working on the load balancer. Okay, so time to go ahead and go to the AWS home page again. Hmm? And search for load balancer. Okay, the load balancers, this one, not that one. Light sail will not work. Okay, we have to look for load balancer for EC2 feature. Okay, if you go to EC2 instance also, in the left hand side you will see the load balancer option over here also. There you go. Okay, this is the load balancer I'm talking about. I hope everybody is with me. Yes, no, maybe. Yeah, just give me 10-15 minutes more. Okay, yeah. All right, so now let's go ahead and click on load balancers. Hmm? And then what we are going to do is that, yeah, now click on this orange color button, create load balancer. Okay, so there are four type of load balancer actually: application load balancer, network load balancer, gateway load balancer, and classic load balancer also is there. So we will start with the classic load balancer. If you scroll down, you will see the classic load balancer. Okay, the previous generation. We will click on create the classic load balancer. And now let's give it a name like my first LB. Okay. Now scroll down. It should be internet facing because we are working with the EC2 instances that has public IP addresses. Okay. Now scroll down and see. One of my friend asked earlier, right? This thing. What if the load balancer fails, right? So you have one important thing, that your load balance is okay, that is different. But here what we are doing, okay, this is very important. We can select different availability zones in one region. So one very important part, that load balancers only work in a particular region. Okay, okay, the load balancers work only for a particular region. Generally, a load balancer is regional. Okay, think of it like this: like AWS region called US East 1 is there. Okay, US East 1. Okay, in that availability zone A will be there, like US East 1A, US East 1B, C, D, right? So your servers can be kept, like you can keep one server in one availability zone, the another server can be from the other availability zone also. Okay, so a load balancer is created inside a specific AWS region and distributes the traffic to targets that are available to it within that region. Okay. Hmm? Yes, it will be shared, Sam. And I hope you're talking about the recording. Okay, so what about the other regions? Okay, suppose you have a region of US East 1 and the load balancer is there, EC2 instances are there. and separately you have a Singapore region having load balancer and EC2 instances. So these are two separate regional load balancer setups. Okay, why? Because AWS regions are separate geographic infrastructures. Okay, so if you want one application to be available across multiple regions, you generally go ahead and work with the global traffic routing layer in front of it. Okay, that is a different concept. Okay, all right. So now let's go ahead and we will check in all the boxes so that if in case we are adding the servers from other regions also, it will cater them also. Okay, now scroll down and you have the security group for your load balancer also. This will play a very important role, but I'm not talking about it right now. I'll talk about in a bit of minute. Okay, so now I'll come back to this. Okay, listeners. Okay, now there are some components of load balancers, okay, that we should understand. Okay, some components or terminologies of uh, load balancers that we should talk about before we proceed further. Okay, so these are the listeners. Okay, who are the listeners? Listener is nothing but something, a listener that is something that waits for incoming connections on a particular protocol or a port number. Okay, for your website, let's say that this HTTP port number 80 will be listening. Okay, or HTTPS port number 443 will be listening. Okay, so think of it like as like I'm listening for the HTTP traffic on port number 80. Okay, so in your load balancer you will configure load balancer protocol HTTP. Okay, load balancer port 80, and here instance protocol will be again HTTP and port number 80. So this is fine. Okay, we don't have to do anything. Then you have health checker. We discussed it earlier also that your health checker is like the protocol where it will be hitting your website is HTTP, and every you can also go ahead with advanced health checker settings and you can see that every this is the response time, like the load balancer will wait for 2 seconds in order to get the in order to get the response from the EC2 instance. Okay, after every 5 seconds the health checker will be sending the request to the EC2 instance for checking whether it is available or not. It is basically ping command generally. Okay, now unhealthy threshold, 2 times if it is not able to listen from or if it is not getting the response back from the EC2 instance, it will mark it as unhealthy. Okay, threshold, healthy threshold, number of consecutive health check success. Okay, 10 times. Okay, you can change it, you can change it as per your requirement also. For now I'm just keeping it like this. I'll scroll down, and this is where you actually, these are the instances, the backend pool, right? Where you are adding your servers or your instances to which the load balancer will be sending the traffic. Okay, now click on add instances. I have both of my EC2 instances up and running. I'll be just confirming and clicking on add. Okay, so both of my EC2 instances are added. Now there are these three options, sorry, two options are also there. Very interesting concept. Cross zone load balancing and connection draining. Okay, let's go back to the PPT and I'll talk about that also before we go ahead and create the EC2 instance. Okay, now what happens, team? There are 2-3 more features I'll talk about. Okay, uh, first of all, what happens that let's say imagine that you have this load balancer. Okay, now this load balancer has two availability zone. Okay, one is that availability zone A and the other one is availability zone B. Okay, now in availability zone A you have kept EC2 1, EC2 2, two EC2 instances. Okay, and this one you have kept another EC2 which is EC2 3. Okay. Again, same. This is the reason that I enabled all subnets or in the networking. Okay, all availability zones of the in the networking, right? The regional base. I'm just taking that point forward. Okay, so without cross zone load balancing, the load balancer may distribute traffic within each availability zone. Okay, uh, with cross zone load balancing on, what will happen that the load balancer will be able to distribute the incoming request across the registered instances no matter which zone they are in. Okay, no matter which zone they are in, the traffic will be distributed in all EC2 instances. Okay, clear, right? This is one thing. So if cross zone load balancing is on, conceptually the traffic can be distributed across all four, three or four healthy instances. So the number of instances in each availability zone doesn't have to be perfectly equal also. Make sense? That is one thing. Now I'll talk about one more feature here. There is a feature called drainage. Okay, very interesting concept again. So let's say that you have a, a load balancer. This is my elastic load balancer. Okay, and actually it should be just a second. Okay, so this is my load balancer, and in the backend I have one EC2 instance, second EC2 instance, and third EC2 instance. Okay. Now these are different users who are hitting my website. Okay, these are different EC2 instances who are hitting my website. 1 2 3 4 5 whatever. Okay, so user 1 came. Now somebody said, right, round robin and all. Okay, this in this case we are using the round robin only. Okay, so user 1 came, I sent it to first server, second server, third server. Okay, so user 1 came, the load balance sent it to first server. Okay, then user 2 came, the load balancer sent it to second server. Okay, right? Then user 3 came and we sent it to third server. Okay, then user 4 came and we sent it to first server again, right? Right? Then user 5 came and we sent it to user 5 came. Yeah. So user 5 came, we sent it to this one, second server. Again, the first user came. Very nice. Okay. Yeah. So now again, this first user came. So which server should we send it to? First, second, or third? Which server should I send it? Yeah. Right? So when user, yeah, third one, right? Definitely third one. But what if I send the first user to which he was sent earlier? Because this user came second time, right? This user came for the second time to access the website. Okay, so if I'm sending it to the last server where he was earlier captured, what will happen that he will be given best uh, experience because already in that server the session is there for that user, right? Hmm? Agree with me, right? Yes, no, maybe. Yeah. So if I'm sending the user the repeated user who came earlier and he was catered in a particular server, and if I'm sending it to the same server, the experience of the user will get enhanced. Okay, right? Now everybody agree that yeah, we should send it to first server, right? Hmm? Okay. So if every time you come back and you're sent to the different servers, you may have to create the sessions again and again, right? And that's what the problem is. Okay. So how does the load balancer handles it? It handles it by sending it to the same server. Okay, fine. But then let's say that this user came 5 times. Now this EC2 instance is being overloaded or not, right? And if a server is being overloaded, then the concept of load balancer is the problem, right? We are losing the concept of balancing the load, right? So then comes the solution called sticky session. Okay, so what happens in session stickiness, that basically the load balancer use cookies. Okay, conceptually the response includes a cookie that helps associate the client with that backend instance. Okay, so on a subsequent request, the user plus cookies will be sent to the classic load balancer, and classic load balancer or elastic load balancer will be sending it to the EC2 instance. Okay, but when your sticky session is on, you you will decide, okay boss, that I will the in what happens in sticky session on for a particular period of time only. If a user is coming within 5 minutes or 7 minutes, whatever the time period that you're deciding, for that particular period of time only he will be sent to the older server. Okay, if he's coming in 7th minute or 8th minute or 10th minute, he will be sent altogether new available server. Okay, now this is actually solving both of the problems, right? The load balancing is also being done, and if the user is coming within the stipulated time period, he will be catered in the older server with the help of the cookies. So the user remains associated with the same backend while the stickiness condition applies. Okay, right? Clear? So you don't actually need stickiness session for static websites, but yeah, in dynamic websites and all, it is really important. Okay, so session stickiness. There's one more uh, uh, feature of the load balancer that I would like to talk about. That is called drainage uh, feature. Okay, so what happens that sometimes what will happen, team, that okay, let me just delete a bit of things here. Okay, now your load balancer can get lot of requests, maybe hundreds of requests in real time, tons of requests also, right? Now let's say that 500 users came, and out of that 200 users were sent to first server. Okay, now when these requests will take time to reach out to the EC2 instance. Okay, so that let's say that these requests have not yet reached out to EC2 instance, but they already have left elastic load balancer. Okay, that means these all 200 requests are in transit state. Okay, in transit state. Okay, in transit mode, in flight mode, whatever you say. Okay, they have not yet reached EC2 instance, and they have already left the elastic load balancer in flight zone or whatever you say. Okay, now in between, before these 200 requests reaching out to the EC2 instance, somehow this EC2 instance got failed. Now what will happen with all other users, sorry, all these 200 requests? What will happen with these 200 requests? These all users will be getting an error, right? Server not reachable or whatever, right? Okay, because they have already been sent to the EC2 instance. Now when they will refresh, they will try again, the elastic load balancer will send them to the new available servers, new healthy servers. Okay, now this is a problem, right? And at times we can cater this at least when the server is going to a known outage, sorry, known maintenance and all. During the outage, you cannot, but during the maintenance, during the patching, during the known troubleshooting maintenance period is going on. In that case, what you can do, the EC2 instance will send a request to the Elastic Load Balancer that, hey boss, I'll be not taking new request, and do one thing, please send me, sorry, please don't send me new requests. Okay, so Elastic Load Balancer will not send the new request to the EC2 instance. Okay, and the EC2 instance will get down. Before getting down, it will cater all the available requests which are already there in the queue of the EC2 instance. Okay, so when you put an EC2 instance into a draining state, the load balancer essentially says that I won't send new requests to this instance, but I'll allow existing connections or the request to finish. Does it make sense to all of us? Yes, round robin with server 2 and 3. Okay, so now I'll go back to the lab. I'll scroll down. Everything is done. So I'll just click on create the load balancer. Okay, once my load balancer is created, I'll have to wait for these two servers to come in service. Okay, but do you think that even if it is coming in service, we will be able to access the load balancer? Because this load balancer has one security group, its own security group also, we will have to enable HTTP over here also. Okay, we'll have to wait. It takes time to come in service. Excuse me. Just give me 1 second, and anyway, we have to wait for these servers to come healthy. Okay. So let's meanwhile these servers are coming in healthy state, we will come. Okay, they came. Okay, okay, now both servers are healthy. Okay, let's try to access. So if you scroll up, you'll see this DNS name. This is the link with which you will be able to access your load balancer. Okay, so I'll copy this and I'll try to access it. Okay, as I was saying, it should not work. Okay, let's see. Okay, so it is not working definitely, but we'll have to remove the HTTP. Yeah, sorry. Okay, it will still not work because the problem is the HTTP, right? So I'll enable that protocol over here, or that port number. Okay, now I'll go to security of my load balancer. I'll look for the security group. Okay, I'll click on the security group of load balancer. Okay, and then what we are going to do is that we will edit inbound traffic. Okay, now you can see that all traffic is allowed. Still, we were not able to access, right? Technically, we should be able to access here, right? But if you can see, the source is customized only from the security group, this one. Okay, which is 8B6. Okay, so that is one another problem. So what we can do, that either I can make it anywhere from IPv4, or I can just allow HTTP only. Okay, with a new rule, and anywhere from IPv4. Okay, I'll save it. Now let's try to refresh it. So it is sending the request to server number 2, right? Now I'll just keep refreshing it, and it will send the request to both of these servers one by one. You can see that, right? I can share this to this in the chat window also. You can also check it out. Okay, just try this out. Okay, and you'll be able to see that. All right, so that is one thing. You can keep refreshing it and you will be able to access it. Now what if I shut down one of the machine? Okay, I'll go to EC2 instances. I'll go to running, and I'll just shut down the first machine. Okay, now let's see. So it is still going to the second server, but it will not. I mean, it will go only to second server only. You can see that, right? Now I'm keep refreshing it. It is going only to second server because first server is now unhealthy, right? So that is how a classic load balancer works. Okay, right? Is it clear to all of us? Yeah. I'll, I would like to talk about quickly the other type of load balancers that you have. The first load balancer is the application load balancer. It works on layer number 7 of OSI, and you can handle more than one applications on top of one load balancer. You can club, okay, and it has intelligent routing based on the path, based on the host, based on the headers. You can create the load balancers. Then you have network load balancers, which is like whenever you need very high performance. Okay, in that case, you can go ahead and make use of the network load balancer. Okay, it works on layer number 4 of OSI, and for TCP, UDP, and TLS traffics, you can just make use of it. Again, you have gateway load balancers, which is used to deploy and scale network security applications such as like the firewalls or intrusion detection systems and all. So very easy way to remember these, like classic load balancer is the basic one. Application load balancer, go for web applications, go for intelligent routing and all. Go for network. I mean, if you need a network based or high performance you need, go ahead with network load balancers. And if you would like to work with the security appliances, go ahead with gateway load balancers. Okay, so that is it from my end, team, for today. I i hope it was a fruitful session for you guys. I will connect with you again tomorrow. Tomorrow there will be the session will be, yeah, I think it is the last session tomorrow. Okay, tomorrow we'll talk about the storage part. Okay, all right. So thank you very much for your for being interactive in the session. Yeah, thanks a lot. Take care. Bye.